Level 1 Flathead Foundations. Side valve V8s. Most people think the V8 story starts with power. It doesn't, it starts with a radical idea that almost failed. The 1930s Ford Flathead V8, displacing just 221 to 239 cubic inches, only made 65 horsepower. Your lawnmower probably makes more. But here's what's wild. This weak engine accidentally created an entire culture. The Flathead side valve design was fundamentally different. Valves sat horizontally in the block instead of vertically in the head, creating that distinctive flat top appearance that gave it its name. This layout seemed clever for packaging, but it strangled airflow. Running on fuel so low octane you could practically smell the impurities. With a measly 6-to-1 compression ratio, it overheated constantly and gulped gas inefficiently. Yet teenagers in the 1940s discovered something Detroit didn't plan for these cheap. Simple engines were incredibly easy to modify. That accessibility sparked the hot rodding movement. Suddenly, working-class kids could build fast cars in their garages. The Flathead wasn't just an engine. It was democratized speed, and that changed everything about American car culture. But this primitive side valve design had a fatal flaw that engineers were about to solve in a way nobody expected.
Level 2, Overhead Valve, Revolution Early OHV V8s. In 1949, Oldsmobile did something that sounds boring but changed everything. They moved the valves. But here's the critical engineering leap. They didn't just relocate them. They completely reimagined the architecture. The new overhead valve design, or OHV, placed valves vertically in the cylinder head
And operated them through a pushrod system from the camshaft below. Why does this matter? Because, overnight, engines could finally breathe. The side valve flathead forced incoming air to make a tortuous 180-degree turn. The OHV created a nearly straight path. The Rocket V8 to 303 cubic inches, 135 horsepower doesn't sound impressive until you realize it made flatheads obsolete instantly. This pushrod-operated overhead valve design increased compression to 7.25 to 1 and delivered 253 pound-feet of torque that you could actually feel slam you into the seat. Post-war Americans were used to underpowered cars. The Rocket made them reimagine what normal could be. NASCAR noticed immediately. Performance sedans suddenly existed as a category. Here's the part that still impacts you. Today, this pushrod OHV architecture, it's the same basic design in modern Corvettes and Camaros. 75 years later, Oldsmobile accidentally created a template so good it transcended generations. But as brilliant as this revolution was, it was about to face competition from an unexpected direction: smaller, lighter, and somehow more powerful. Level 3 Small Block Dominance. Compact V8s. There's one engine family that refuses to die, and it's not what you'd expect. The Chevy small block first appeared in 1955. It's still in production today. That's 70 years of one basic design, something almost unheard of in engineering. But here's what most people miss. Chevy wasn't alone in this revolution. Ford fired back with the Windsor series, particularly the legendary 289 cubic inch variant, while Chrysler countered with their LA series engines. These three formed the holy trinity of small block V8 South that defined American performance. At just 575 pounds, these compact OHV engines weighed far less than their predecessors but delivered 162 to 375 horsepower. They ran on regular gasoline, later gasohol, even LPG or compressed natural gas when needed. The magic was versatility. The same basic architecture powered your grandmother's Impala, dominated Trans Am racing, and pushed speedboats across lakes. The aftermarket exploded. You could build anything from a fuel sipper to a tire shredding monster using the same block. Engineers achieved a holy grail ratio, 1 horsepower per cubic inch, then exceeded it. Mechanics still swapped Chevy small blocks into everything from vintage hot rods to modern trucks, though Ford and Moper loyalists will fight you in the comments about which one's truly best. But in the 1960s, some engineers asked a dangerous question. What if we stopped being reasonable and just built the biggest, most powerful thing possible? Level 4. Big block muscle, high displacement NAV. The 1960s were insane, and the engines prove it. Chrysler's 426 Hemi made over 425 horsepower when muscle cars ruled American streets. But here's what the brochures didn't tell you. These engines were borderline irresponsible. The name Hemi refers to hemispherical combustion chambers dome-shaped cavities that allowed massive valves to sit at optimal angles for maximum airflow. Chrysler's competitors used wedge head designs, which achieved similar goals through different geometry, but with the same obsessive focus, optimizing flame propagation and breathing efficiency above everything else. Compression ratios exceeded 11:1 so high they required premium lidded fuel and could destroy themselves on bad gas. The fuel evolution tells its own story. We'd gone from 6:1 compression sipping low-octane fuel in the Flathead era to these monsters demanding high-octane leaded premium just to survive. Engineers weren't worried about fuel economy, emissions, or reliability. They wanted factory cars, running low 13-second quarter miles, and they got them. Racing versions burned specialized alcohol blend fuels to withstand even higher compression and timing advance. This was naturally aspirated power taken to its absolute limit, pure displacement and brilliant head design. No turbochargers, no tricks. Just massive cubic inches and obsessive attention to how air moved through the engine. Then the 1973 oil crisis hit. Emissions regulations arrived, and suddenly these glorious dinosaurs faced extinction. Manufacturers had to completely rethink what a performance V8 could be. What came next seemed impossible. More power with less guilt. Level 5. Modern performance and efficiency. EFI, emissions era V8s. Here's something that shouldn't exist. Engines making 638 horsepower while meeting strict emissions standards and getting decent fuel economy. Yet GM's LS series and Ford's Coyote 5.0L do exactly that. But these two took completely different architectural paths to the same destination. GM doubled down on the classic pushrod OHV design pioneered in 1949, refining it with modern materials and electronics. Ford said, forget tradition, and went with dual overhead cam, 4-valve per cylinder heads D, OHC. Architecture that's mechanically more complex, but breathes incredibly well at high RPM. The secret to both? Electronics changed everything. Computational design optimized every millimeter electronic fuel. Injection metered fuel precisely, and variable valve timing allowed the engine to adapt its personality constantly. They run on unleaded gasoline or E10 gasohol as standard. We've come full circle from those. Low-octane Flathead days to fuel containing 10% ethanol. Many switch seamlessly to E85 and 85% ethanol. Blend that's essentially returning to the alcohol-based racing fuels of the muscle era, now available at your local pump. Some truck variants even burn compressed natural gas or LPG. Aluminum blocks and heads cut weight dramatically. Sensors monitor hundreds of parameters per second, adjusting ignition, timing, and fuel delivery faster than any human could react. The result feels like cheating. LS engines in Base Corvettes making over 450 horsepower while passing emissions tests and achieving 30 mpg on highways. Millions have been built, creating a massive modern aftermarket. But some engineers looked at these balanced engines and thought, what if we stopped being sensible? That decision created monsters. Level 6, Forced Induction Fury, High Boost Street V8s. Something shifted in the mid-2010s when Dodge casually released a sedan making 707 horsepower. Not a limited production supercar, a 4-door family car you could auction with child seat anchors. The Hellcat's Supercharged 6.2-liter V8 redefined streetable performance. Ford's GT500 and Chevy's LT5. Join the madness, all running 10 to 15 psi of boost through Roots-type or twin-screw superchargers, cramming air into the cylinders. These aren't fragile trailer queens. They have warranties. They run. Premium pump gas, usually E10 blends, though enthusiasts quickly discovered E85 unleashes even more power. That high ethanol content resists knock far better than straight gasoline, letting engineers run. More aggressive timing and boost. The fuel chemistry evolution, it started with 6-to-1 compression on. Low-octane flathead fuel had now reached a point where high ethanol blends enabled boost levels previously impossible. Forged internals, strengthened blocks, upgraded cooling systems with massive intercoolers. Everything reinforced to handle cylinder pressures that would grenade lesser engines. Advanced engine management prevents detonation through constant monitoring and adjustment. Retarding timing or enriching mixture, the instant sensors detect trouble. Here's the absurd part. These factory vehicles run 10-second quarter miles. That's faster than purpose-built race cars from just 20 years ago. You can drive one to work, pick up groceries, then humiliate supercars at stoplights. But even this extreme wasn't enough for the truly obsessed engineers who were about to push into 4-digit horsepower. Level 7, 1,000-plus horsepower territory, extreme and specialized fuel V8 South. We've reached the edge of what's physically possible from internal combustion. The Dodge Demon 170 produces 1,025 horsepower. That number sounds fake until you watch it run an 8.91-second quarter mile on street tires. This is factory equipment. Chevy's upcoming twin-turbo ZR1 is chasing similar numbers. How? Race-grade internals, massive forced induction. And here's the critical part. The fuel chemistry has evolved to its ultimate form. These engines employ direct injection systems operating at over 2,000 psi. That's fuel being injected at pressures that would make those old flathead carburetors explode. Combined with port injection for optimal fuel atomization under all conditions, the fueling system alone represents more computing power than the entire Apollo moon mission. They're calibrated specifically for E85 high ethanol blends that resist knock far better than gasoline, allowing extreme boost and timing. Advance. We've gone from 6-to-1 compression on low-octane sludge in the 1930s to 11-to-1 on leaded premium in the muscle era to these modern monsters running high boost on carefully engineered ethanol blends. On regular pump gas, they make significantly less power as computers retard timing to prevent catastrophic detonation. Some extreme builds use pure methanol or dual fuel strategies, injecting different fuels for different operating conditions. Sophisticated metallurgy and aggressive cooling barely contain the violence happening inside these cylinders. The Demon runs sub-9-second quarter miles while remaining street-legal and emissions-compliant performance that dominated professional drag racing just decades ago. This represents the absolute peak of V8 development, the limit of what current materials, technology, and fuel chemistry allow. And honestly, it feels like we've reached the end of an era, because what comes next probably won't burn gasoline at all.